Logical design in data warehouses. Now, your organization has decided to build a data warehouse. You have defined the business requirements and agreed upon the scope of your application and created a conceptual design. Now, you need to translate your requirements into a system deliverable. To do so, you create the logical and physical design for the data warehouse. You then, 1, design the specific data content. Then the next thing is you define the relationships within and between groups of data. Then the third thing is to define the system environment supporting your data warehouse. And the fourth thing is you define the data transformations required. And finally, the frequency with which data is refreshed. Logical design is more conceptual and abstract than the physical design. In the logical design, you look at the logical relationships among the objects, different objects. In the physical design, you look at the most effective way of storing and retrieving the objects as well as handling them from a transportation, backup, and recovery perspective. Then you orient your design toward the needs of the end users. End users typically want to perform analysis and look at aggregated data rather than individual transactions. However, end users might not know what they need until they see it. In addition, a well-planned design allows for growth and changes as the needs of users change and evolve. Do not assume at any given point in time that one design fits all different types of scenarios. You should be ready to modify the design as you discover more newer needs of information which may not have been spelled directly for you, such as the need to expand the database if the need ever arrives. A logical design is conceptual and abstract. You do not deal with the physical implementation details yet. You deal only with defining the types of information that you need. One technique you can use to model your organization's logical information requirements is in entity relationship modeling. Entity relationship modeling involves identifying the things of importance, which is an entity, the properties of these things, which are attributes, and how they are related to one another, which are relationships. The process of logical design involves arranging data into a series of logical steps or relationships called entities and attributes. An entity represents a chunk of information. In relational databases, an entity often maps to a table. An attribute is a component of an entity that helps define the uniqueness of the entity. In relational database, an attribute maps to a column. To ensure that your data is consistent, you must use unique identifiers. A unique identifier is sometimes called a primary key, and this is something you add to tables so that you can differentiate between the same item when it appears in different places. While entity relationship diagramming has traditionally been associated with highly normalized models such as OLTP applications, the technique is still useful for data warehouse design in the form of dimensional modeling. In dimensional modeling, you identify which information belongs to a central fact table and which information belongs to its associated dimension tables. Now, entity represents a chunk of information, as previously stated, in a relational database. An entity often maps to a table, and which in this example provided, this could be representative of the entire table. Then, the month attribute would be a component of the entity that helps define the uniqueness of the entity. In relational database, an attribute map to a column. Now, in dimensional modeling, instead of seeking to discover atomic units of information such as entities and attributes and all of the relationships between them, you identify which information belongs to a central fact table and which information belongs to its associated dimension tables. You identify business subjects or fields of data, define relationships between business subjects, and name the attributes for each subject. Your logical design should result in item number 1, a set of entities and attributes corresponding to fact tables and dimension tables. And number 2, a model of operational data from your source into subject-oriented information in your target data warehouse schema. You can create the logical design using a paper and pen, or you can use a design tool such as Oracle Data Warehouse Builder.